let's get into it. So guys, like I said, what we're doing today is we're drawing some graphs. I did say this to you on Wednesday. Most of the time we will give you a Cartesian plane. So obviously because I'm not there with you, like in a classroom. Oh, I'm finished. I can't give you a set of axes. If I was your teacher in a classroom, I would print these out for you and I would give them to you. You could then cut out and paste and do what you needed to do. Most of the time in a test or an exam, we will give you the Cartesian plane. We don't expect you to be able to draw it yourself just because it wastes time in a test or in an exam. But please remember that we could expect you to. So your Cartesian plane on which you're going to draw a graph is your two axes, X and Y. Please remember X is always horizontal, Y is always vertical. That never changes. And remember your axes are like big number lines. So we've got 0, 1, 2, 3, etc., etc. On the x-axis, to the right is all positive, to the left is all negative. Oops. And like I say, it's done in a number line fashion. On the y-axis, everything above the x-axis is positive. Everything below the x-axis is negative. So if you are expected to draw your own Cartesian plane, I've now explained how to do it. We also have discussed this before. So this is how you would draw your own if required to. Like I say, most of the time we do try and give it to you, but you never know. So just in case. So that's our Cartesian plane. That's what we need to use as we start to draw our graphs. Copy this for later because I don't want to have to do that again. Right. So guys, whenever we draw a graph, what we need is a rule or a relationship to draw. So I can see that in question A, I have been given a specific relationship that I now need to plot a graph for. And that relationship is y equals x plus 1. So our goal here is to take the equation and we now want to graph, or we can say plot, this relationship. And that is the entire point of a graph. So we've spoken about this already. However, just as a reminder, the whole purpose of drawing graphs, whether it's in data handling, so drawing like a pie chart or a bar chart, or drawing a graph like what we're going to do today, is to show some sort of relationship. It's to give us information. So as we start to draw these graphs, just always bear in mind somewhere in the back of your head that what you're doing is you're representing a relationship. We are representing the relationship that exists here between our input value X and our output value Y. Now, I've said this to you before, I'm going to say it to you again. Whenever you draw a graph, a table is quite a useful tool to have. Okay, it's a useful tool to have because we know, because of our past lessons that we've been doing, that we can always use a table to find our X or our input and our output values, and it gives us our coordinate pairs that we can then plot. Right, now guys, if you have to draw your own table, and again, I said this on Wednesday's lesson, but I'm going to say it again. If you have to draw your own table, you can pick your own input values, right? Whatever you want. My suggestion, and again, I said this on Wednesday, is you pick some negative, you pick 0, and you pick some positive. So for our tables today, we're going to work with -2, -1, 0, 1, and 2. I've got some negative values. I have some positive values. And I have 0. And that's what you need to be picking when you have to pick your own input values. Sometimes we'll give them to you in your table and you don't even have to do anything. But if you do have to pick your own input values, pick at least one negative, pick 0, and pick at least one positive. That will allow you to draw a very decent graph. Right, so guys, what we want to do is we now want to find these output values. So great, we've got inputs, but doesn't help me to draw a graph. I need the output. So remember, what we do is we take our input value and we use substitution. So if I've got x equals -2, I know that my rule is y equals x plus 1. So I'm going to use substitution and replace x with that -2 in order to find y. So now I have -2 plus 1, which gives me -1. And so my output value here is -1. Now we do exactly the same thing with all of our other input values. So if we look at x equals -1, y is equal to, and I substitute my -1 plus 1, -1 plus 1 is 0. So my output value here is 0. So whenever you are trying to find your output values, you just substitute an input in order to get y. Right, so what I want on the chat is the rest of your output values. I'm numbering them A, B, and C. Let's see what output values we get there. And then we'll look and see how we take the input and the output and we go and plot a graph. Hey, sorry, my cat's playing with my charger. No. Okay, so guys, use your substitution, get your outputs, and then we'll plot a graph. If you feel super comfortable that you can go and plot a graph already, that's absolutely fine. I'm not going to stop you. I am going to do the plotting together with you just so that you know how we do that. What, my Baba? What do you want? Just remember to number your answers exactly like you guys are doing, so keep it up. That's it. Good, guys. Keep those answers coming. I'm going to give you 30 seconds. Nice. Okay, guys, so if we now go and substitute in our x equals 0, we've got y is equal to 0 plus 1, which gives us an output value of 1. If we've got an input value of 1, 1 plus 1 is 2. Input value of 2, 2 plus 1 is 3. Okay, so firstly, we now have a set of coordinates. If I write those down, remember coordinates are always x first and then y. So my coordinates here are going to be -2, -1, -1, 0, 0, 1, etc., etc. And because we have this coordinate, remember, this can now be plotted on our Cartesian plane. The next thing that I want you guys to notice is if you just look at your output values that you have just found. So if we go and have a look at all of these values we've just gotten here, I hope what you see is that the pattern is that they are increasing. Each one, we're going up by 1, or from each output value, we're going up by 1. And so we are increasing our output values. Now that's going to be important when we plot this relationship, because remember, the whole point is that my graph does represent the fact that the y values increase as x increases. Right, so guys, what we do is we plot our points. We have spoken about this before, but just a quick refresher of how to plot a point. So my first point is -2, -1. -2 is x, so I find that on my x-axis. -1 is y, I find that on my y-axis. And essentially, if you drew a line down from -2 and across from -1, where those two lines meet, you plot your point. Right, so that will be where our coordinate goes. I just don't want those lines. I'm going to take them off. So here's my coordinate, -2, -1. Now, grade 8s, you don't have to write the label there. You only write the label if we ask you to label your coordinates or label your points. I am going to label them just that you can see which point is which. Right, the next one is -1, 0. So -1 on the X, 0 on the Y means it's on the axis. We then have 0, 1, which is now on the Y axis, 1, 2, and 2, 3. Now guys, hopefully what you're seeing as you plot these points is that they're all starting to go up in a line. And this is where our graph comes in. Now, if you are drawing a graph, you have to draw the line. A graph is now this visual representation. I'll help if I could draw the line properly. We have to join these dots. I take my ruler and I join my points. Okay, I'm going to do that a little bit better. A couple of things that I want you to be seeing as I'm joining these points, guys, is the fact that I'm extending my line to the ends of my Cartesian plane. So imagine this as like a piece of paper. I go to the end of the Cartesian plane. This is to show, and we put arrows on the end to show that this graph just keeps going, goes all the way to infinity. We obviously can't draw that. So we put little arrows on the end to represent that fact. I also want you to see that I haven't drawn a tiny little line. So I don't want to see a graph that looks like that. Okay, that, like, yes, it's a graph, but it doesn't very accurately represent my relationship. We want to extend that line as far as we can to show that this relationship keeps going. Alrighty, guys, so we said, if you were following what I was going on about earlier, we said, or we spoke about the fact that these Y values are increasing. So it goes from -1 to 0 to 1 to 2 to 3. They are increasing. And if you look at your graph is increasing. Okay, it's going up from left to right. So this is an increasing relationship. And as I said, the whole point of you drawing a graph is to represent a relationship. By this line going up from left to right, we can see that as X increases, so does Y. So as these X values got bigger, so did the Y values. And that line now shows that relationship. So it's really important that once we've drawn the graph, we do go back and see the relation to the equation or the relation to even the table. It's increasing, it shows that relationship. And so we have been able to visually represent the equation y equals x plus 1. Right, grade 8, any questions? Otherwise, let's take screenshots here and then we're going to have a look at another one. So please remember, raise your hands, ask your questions when I let you know. Otherwise, always just put your questions immediately on the chat. We'll get to them as I see them. 10 more seconds for screenshots. Okay, let's have a look at another one. Right, so now we've got a relationship of 3x minus 2, y equals 3x minus 2. I'm hoping that I've don't have to waste my time again. Y equals 3x minus 2. So again, we need to set up our table, x and y. We're going to use the same values, no points in trying to rock the boat here. So what I want from you guys is to find these outputs for me. So A, B, C, D, and E. Use the rule that I've given you. The rule that we are working with in this specific question now is y equals 3x minus 2, like I said earlier. So you're going to substitute into that equation and you're going to find those outputs for me. Again, if you're feeling super comfortable, you can go immediately and start plotting the graph. I'm absolutely fine with that. Let's first find the outputs, though, for those of you that aren't feeling 100% comfortable just yet, and then we'll plot the graph. Good. Keep those answers coming in. Okay, guys, and just be careful here. The rule is 3 times x minus 2. So make sure you are doing your operations correctly. Good, grade 8. I love that we're starting to get into a habit of just putting all of our answers at the same time. Love it. Nice, guys. Right, let's have a see. So I'll do like the first 1 or 2 in terms of showing you the substitution. Obviously, if you need help, you just shout. But if we've got x equals minus 2, we're going to substitute into our equation, which is y equals 3x minus 2. So I'm going to replace that x with a negative 2. So I've got 3 times negative 2 minus 2. Figure out, how does this make sense, my girl? Right. Positive 3 times negative 2 is negative 6 minus 2. And then we have to obviously simplify that. So that gives us y is equal to negative 8. So my first output here is negative 8. We then substitute in the negative 1. So y is equal to 3 times negative 1 minus 2. 3 times negative 1 is negative 3 minus 2. So we get an output of negative 5. And so we keep substituting. Our next one is going to be negative 2. Or our next output rather is negative 2, 1, and then 4. So we've got our inputs, we've got our outputs, and now we can go and plot our graph. So remember, coordinate pairs, that's the whole point of the table to help us out. Negative 2, negative 8, negative 1, negative 5, and so on. Now, guys, you don't have to write down the coordinate pairs under the table like I'm doing, but I find it quite helpful to then just have them listed for myself, just so that I can double check exactly what I'm plotting. So the first one, negative 2, negative 8, I need to make this longer. Right. So negative 2 on the x-axis, whoopsie daisies. Down to negative 8 on the y-axis, I've just made mine longer. Negative 2 down to negative 8. Everything is in the way. Yeah. There's my first point. Next coordinate, negative 1, negative 5. 0, negative 2, and so we keep going. Now again, hopefully what we're seeing is that as we plot these points, they're forming this relationship, and we can see that we're able to draw in a line to represent this relationship. Right, so you grab your ruler. It has to be with a ruler, especially if it's a straight line relationship. We grab our ruler and we join our coordinates. Again, I've not done a very good job here, so let's just sort that out. Okay, there we go. And we have our relationship. Again, guys, hopefully we all agree it's an increasing relationship. It's going up from left to right. That makes sense. If we go and have a look at our output values, we're going from -8 to -5 to -2 to 1 to 4. They're going up, right? Those values are increasing. So as the X values got bigger, so did the Y values, hence an increasing relationship. All right, guys, any questions, concerns, queries? Otherwise, you're going to try the next one by yourselves completely, graph and table. No questions. Good, guys. Hopefully we'll get to some fun graphs today. Right, so this is a relationship I want you guys to try all by yourselves. Y equals -2x plus 1. The only information I will give you is obviously your inputs. But I want you to try this by yourselves. Ziva, just quickly, just want to make sure that I am on the same page as you. When you say, do we have to write it, do you mean this x equals -2 for the substitution? If it is, no, you don't have to. You can do your working out as you choose to, however it makes sense for you. I just sometimes write it there to show that that is what I am going to substitute, but you don't have to. It's not a necessity. Okay, brain break should not be showing because I haven't shown it yet, so that's a little bit concerning. Right, we're trying this one by ourselves, please. I want the output values, and I want you guys to draw the graph for me. No, fine. So remember your substitution. Guys, what you do now need to be careful of is the fact that your rule is -2x. So the coefficient in front of your x is negative now. So just bear that in mind when you do the substitution, because it obviously does affect how you do your operations. Lubanzi, the line will not always be straight, no, and that's why I was saying earlier, hopefully we get to some fun graphs. I'll point out how you can identify that it won't be straight in the equation. Right now, all we've been dealing with is x term. So x plus 1, 3x minus 2. It hasn't been anything weird like x squared or to the power of x or anything like that. When we do get something a little bit weird going on with x, then we no longer have a straight line graph. But hopefully we're going to get to those just now, and then I'll point it out to you. So no, it doesn't always have to be a straight line. In grade 8 and particularly grade 9, you only work with straight lines. But if you choose to do maths in grade 10, you no longer work with just straight line graphs. You do start to work with other types of graphs. So it is good to see them, and we'll hopefully have a look in a second. How can you guys see the brain break? Have I just like... Oh, okay, you can see the first bit of the brain break. There we go.
Yeah, they couldn't see the brain break. The way that they saw of brain break, you guys. Come on.
I was panicking. I was like, how is this happening? You guys are like,
oh, they're
I
not.
don't know.
I know they're geniuses, but they couldn't see that far. They only saw the parts of the brain break.
Guys, this is my cat's lying next to us right now. She's joining in with the lesson. She's...
Oh, wow. I saw her like, climbing in on top of you, and
she's being so needy. She's like, Mom, it's time now. I want to cuddle. Okay, guys, so outputs and a graph. Let's see how we're going. Remember, as you're going, if you feel a bit stuck, just put your question on the chat or send Yolanda or myself a message. Will help you. Guys are doing really nicely though. You should be proud of yourselves. Clearly, we're all studying for exams. In the zone. Good. I'm glad we're putting some answers there on the chat. Obviously, guys, you won't be able to put a graph on the chat, but keep those outputs coming. You're looking good. I love that you all also all automatically just number your answers. Awesome. Okay, I'm gonna give you another minute or so, and then I'll start doing some working out. The outputs are looking good though, and hopefully our graph just as good. All right, so grade 8's in the table. You'll see the outputs that you should have gotten. Most of you got that. If you didn't get one of those outputs, when we do questions in a second, please just ask for which one you're confused, and I can show you the substitution. But hopefully we all got those. Like I say, from the looks of what I saw on the chat, you guys did get them all. So now we just have to plot our graph. So we take these points and we write our coordinates, so -2, 5, etc., etc. And then we can go and plot these points. Right, so the first coordinate that we need to plot is that -2, 5, so -2 up to +5, just be careful there. And then I go and write the wrong thing down. -1 up to 3. And so we keep going. -3. Now guys, hopefully what you see is, again, you have a straight line. It's just now decreasing. Okay, we'll chat about why that is in a second. So we take our ruler, we join all of our points. Obviously, I've not joined my points very well, but again, I will fix that. Right, join your points and you've got your graph. Now, the reason this is decreasing, and I'll write it on the graph in a second, is again, if we have a look at our output values, we're going from 5 to 3 to 1, and all of those values are decreasing. We're going down now. And so this is why my graph represents that, because again, a graph represents what the relationship is. So this is now a decreasing relationship. Because as the X values got bigger, so we went from -2 to 2, our Y values actually got smaller. Right, we can also tell it's decreasing because remember what we had here was a -2, right? That -2 tells me that we are going down. We have that decreasing relationship. And we spoke about that when we did number patterns. So that should be fairly familiar for us. But we've got a decreasing relationship here because my line's going down from left to right. Any questions, grade 8s? Anything we're not too sure about? Anything we want to double check? Right, I am going to go to the brain break, but we don't have like a lot of time. So I'm going to give like 5 minutes for the brain break. If we don't get it, we don't get it. That's fine. We'll move on. We'll just do it on Wednesday. I'm sure you guys will get it, but I don't want to waste time unnecessarily. Right, so I'm just going to wait here if you need screenshots. Again, please ask if you're not 100% sure where I've gotten a value so that I can explain it. Otherwise, here's your brain break for the day. You guys know the drill. We are looking for the value of the very last equation down here. All right, so let's try that. I need to do it as well. Oh. Sorry, baby. Good. Also remember, guys, on the chat, you're welcome to obviously put answers there as you go along, but the first person to get the final answer will be the one I call upon. It is a little trickier than you would think it would be. It definitely is. It looks deceptively easy. Keep trying. I'm going to give you another minute. Oh, Zandile, you were the first one. Excellent.
Zandile is the winner. Well done.
If you want to raise your hand to explain it for us. Hope we also enjoyed the joke. Nice, Zandile, well done. Okay, how did we do it?
Morning, afternoon.
Hi.
Evening.
I know, it's
How are
all of those
you?
things. I'm good, how are you?
I'm good. So the smiley face, I just found out that it's 9. So 9
Good.
plus 9 plus 9 is 27.
Good.
And the winking face is 8. So
Excellent.
8 plus 9 times 8 is 8. So 8 plus 8 times 5 is 48. So the double winking faces is 8 plus 8. 8 plus 8 is equal to 16.
Good.
And the third face is equal to 5. And I added 8, 9 plus 9, which is 18.
Excellent.
And if I add and multiply it all, it gives me 106.
Excellent, Zandile. Well done. So, guys, 106, excuse me, 106 there was your answer. Just always remember, obviously, guys, you need to be applying BODMAS. So the 9 times 8 has to happen first, the 8 times 5 has to happen first, and the 5 times 18 has to happen first. And that gave us our final answer there of 106. Very nicely done and well done. I did see a couple others also get 106. So very well done. But good, well done, guys. So let's have a look at some fun graphs. So this was the question of, is it always going to be a straight line? No. Now, hopefully what you see here is, okay, this is very big as well. Hopefully what you're seeing here is that this equation that I've given you, so the fact that this is y is equal to x squared, that is automatically different to what we were looking at earlier, right? We had like a negative 3x plus whatever we had 2x minus 1 or 2x plus 1. We just had an x term and then a constant. There was no squares involved, but now there is a square involved. This is now where our graph is no longer a straight line graph. All right, so let's have a look. We're again going to do exactly the same thing as what we were doing earlier, input and output values. And we now need to find those. Now, I am going to do this working out with you just so that we do make sure we get the correct answers. So if we take the x equals 2 input, we would have y is equal to 2 squared, which gives us 4. So my first output is 4. X equals negative 1. It would also really help if I did the right thing here. Okay, so let's try that all again. X equals negative 2, not positive 2. We'll get to positive 2. So y is equal to negative 2 squared. Now remember, that means negative 2 times negative 2. A negative times a negative is a positive. So we end up with 4. So my output was right, to just put in the wrong input. Right, x equals negative 1. Y is equal to then negative 1 squared. Again, that means negative 1 times negative 1, which is positive 1. X equals 0. Y is then equal to 0 squared, which is just 0. Right, if we now go to the positive, so x equals positive 1. Y is then equal to positive 1 squared, which just gives us 1. And the last one, that x equals 2 that I made an oopsie with, y is then equal to positive 2 squared, which gives us 4. So what I want you guys to see is that here, because of the squared, so let's just get some colors going on here. Because of the squared, I've got a 4 and a 4, a 1 and a 1. So there's the same answers, negative and positive. And that's going to create an interesting looking graph for us. Remember, we've got some coordinates here that we can now plot. So if we just write our coordinates down for ourselves, negative 2, 4, negative 1, 1, etc., etc. And now we plot these points. So negative 2 up to 4 is our first coordinate. Then we've got negative 1, 1. 0, 0. Remember, this is our origin. It's where the two axes cross. Then we've got 1, 1. And finally, again, 2, 4. Now, guys, hopefully what you're seeing is that this is definitely not a straight line. Okay, now, the only graph we ever draw with a ruler is a straight line. If it's not a straight line, we draw it as a curve. So this actually forms like an umbrella cup shape, which obviously I can't do right now. Let's try again. There we go. So it forms this umbrella U cup shape graph. And that's all because of the squared. So this squared makes the U shape for us. The reason being is because we've got the symmetry. So whether it was negative 2 or positive 2, we had positive 4. And so that almost forms a mirror image along my y-axis. So if you imagine this y-axis as a mirror, you're creating a mirror image on either side. And that's because of the squared. We don't always have to have a straight line graph. And like I say, the equation of the rule will tell you that. So like I say, this squared, it will then be the U, the cup shape type of graph. Right, we do get other types of ones, and I think I've got another one coming up. But let's just double check. Does anyone have any questions about any of this? I'll leave it up, obviously, if you want to take screenshots. But these, we can definitely ask you, all right? We can definitely ask you to draw these types of graphs. You work a lot with these types of graphs from grade 10. So any questions, feel free to raise a hand or put it on the chat, other one, whichever you're more comfortable with. Okay, so let's have a look at another one. So I'm going to just skip that one for a second. I want to chat about this one first, just in case we run out of time, because this is another interesting type of graph that we can get. Okay, let's get that right. Okay, so if we have a look at our rule, again, do you see that it's not the normal 3x plus 1 or x minus 2? The rule is a little bit different here. What my rule is here is y is equal to 2 to the power x. Okay, so now I've got an exponent that is x. So we're going to do exactly the same thing. Inputs, outputs, we're going to do -2, -1, 0, 1, 2, and we're going to substitute. Now, again, I'm going to do the substitution with you, mostly because of the fact that x is in the exponent. We have to now go back to our exponent rules, which was a while ago, so that's why I'm going to do it with you. Okay, so the first one, -2. Y is equal to the power -2. Now, guys, if you substitute this into your calculator, and obviously I have not got my calculator next to me, so we'll just use the scientific one. Nope. If we substitute this in, nope. Okay, so 2 to the power -2. That gives me an answer of 1/4, right? It goes back to our exponent laws that we spoke about. I want to say in term 1, term 2, but literally if you just type that onto your calculator, you will get your answer. So this is equal to 1/4. If we do the same thing with -1, so y is equal to the power -1, again, on your calculator, you get 1/2, 0, y is equal to 2 to the power 0. Now, again, go back to exponent laws. Anything to the power of 0 is 1. So y is equal to 1. Nice and easy. X is equal to 1 and x is equal to 2. Substitute y is equal to the power 1, which is just 2. And substitute y is equal to the power 2, which we know is 4. So we've got all of our outputs here that we can now fill into our table. So it was 1/4, 1/2, 1, 2, and 4. So if we just write down our coordinates for ourselves, -2, 1/4, blah, blah, blah. We can now go and plot these coordinates. Right, so if we start plotting. Now, guys, 1/4 is going to lie somewhere between 0 and 1, and it's probably going to be closer to the 0. Like, just imagine it on a number line. That's what axes are. So -2 on x up to about 1/4 on y. That's more or less. It's a bit of a guesstimate, but you get it as accurate as you can. Next one was -1/2. So now it's halfway between 0 and 1, which is about there. Plot our point. And so we keep going. 0, 1, 1, 2, 2, 4. Now again, hopefully we see that this is definitely not forming a straight line. Okay. Oh, golly. You can't lie there. It's forming a sort of curve. It's going up. So again, because it's not a straight line, we don't use a ruler. We now go and draw this curved sort of J looking shape. Now, guys, this is what we call an exponential graph. Now, from your social sciences, you've probably heard of like exponential population growth. So if we start thinking about like the human population, this would be a graph that shows the human population. It's growing exponentially. If you want to think about like when you get sick, like let's say you get the flu or something, that's a virus, or you get sick with a bacterial infection. the bacteria grows exponentially. So this type of graph has a lot of real world applications for us. And it's called exponential because mathematicians aren't super creative sometimes. There's an X in the exponent and it creates this curve going upwards. So this one has a lot of real world applications, particularly with things like population growth. And we can graph out that relationship.